so good. Now we can get into the actual coalescent. We've got a little bit of the mathematical tricks that we're going to need. So the coalescent, again, we're going to be looking at a population of individuals, or a population of alleles. And we want to ask what the shape of the tree is. So a major thing we're going to be interested in is like, how long ago did two individuals diverge from each other? So even though I'm drawing this as a line of individuals, we're going to assume that these individuals are all mixed up, right? There's no structure here. These are just individuals in a freely mating, freely moving population. So if we take two individuals at random, let's say this one and that one, so the first question we could ask is, how long ago did these two alleles diverge from each other? Okay, so what we're asking there is, in a population of n individuals, so this is about 12 or so, what's the probability, how long ago did these individuals diverge from each other? So, to get at that, we're going to go back in time, one generation at a time, and think about what the chances of things happening are. So right now we're at time 0, the present, and then we're going to go, we call it time 1, but kind of mean time -1, one generation in the past, and so forth. So what's the chance that these two individuals coalesced, that these two individuals have the same ancestor, are descended from the same ancestral allele in the previous population? So when that happens, when two individuals have a common ancestor, we're going to call it that the lineage is coalesced. Because we're going to draw the lineages up like this, independent, and then at some point they're going to come together, they're going to coalesce. Okay, well, in the simplest case, if we imagine that the population size is the same from generation to generation, and that it's random mating, and that none of these individuals is any better than the others, then basically what we're asking is, so this individual has some parent, and this individual has some parent, and we're asking what's the chance they're the same parent? So this individual either has the same parent or does not have the same parent. And it doesn't really matter, if it's not the same parent, it doesn't matter which one we draw, because we've said it's a freely mixing population. And so we can go back generation by generation and ask, do they or do they not have the same parent? And then eventually, they will have the same parent, and we say they have coalesced. Okay, so our first question then is, how many generations, what's the chance that these individuals diverge? The last generation, the generation before, and so forth. Okay, well, if in every generation there are n individuals, then the question is, just randomly, what's the chance that they both pick the same one? And I think the easiest way to think about this is, if this individual has this parent, then just what's the chance that this one has the same parent? And well, if there's n individuals and it's random, then the chance that this individual has the same parent as this one is just 1 over n. Okay, so the probability that they coalesced one generation ago is 1 over n. Well, what's the probability that they coalesced 2 generations ago? Well, for that to happen, the first thing that has to happen is in the previous generation they have to have not coalesced, the chance of which is, if you pick any one but that, times the chance that they coalesce in the second to last generation. And so you may see that this is a waiting problem, like we were just talking about. How long do we have to wait for them to coalesce? Well, the chance that they coalesce in any generation, the probability that they coalesce in any generation, p is 1 over n. So this is just a waiting problem with p of 1 over n. And so we can then write down the probability we can, in general, write down the probability that they coalesced t generations ago as n minus 1 over n to the t minus 1 times 1 over n, just a classic waiting problem, And the expectation, on average, they coalesced n generations ago, or 1 divided by p, which is equal to 1 divided by 1 divided by n, which is equal to n.